So we will see another numerical in the losses of pre-stress. A concrete beam of rectangular section 100 mm wide and 300 mm deep is pre-stressed by 5 wires of 7 mm diameter located at an eccentricity of 50 mm. The initial stresses in the wire beam 1200 Newton. So it is given a rectangular beam 100 mm wide and 300 mm deep, having 5 wires at an eccentricity of 50 mm. It is having P naught is equal to 1200 Newton per mm square. Estimate the final loss of stress in steel due to creep of concrete according to the Indian Standard Code method IS 1343. The relative humidity is given as 50% and FCK value also given. FCK value is given as 60 MPa. So the solution we start here. We will have some basic assumptions. That is, the Young's modulus of steel is not given, so we will take it as 210 kN per millimeter square. FCK is given as 60 Newton per mm square. Now the area of the section, that is 300 into 100 mm square. Moment of inertia BDQ by 12, you will get this value. EC, that is the Young's modulus of concrete, you will take it as, it's not given here, so you will take it as 5000 root FCK. That value you will get it as you get this value as 38729.83. so from here substituting that value, you will get the modular ratio M as ES by EC, you will get as 5.4. so up to this you know. And the pre-stressing force, you have 5 tendons of 7 mm diameter. Area of pre-stressing force is 1200, so you will get this in Newton. The eccentricity is given as 50 mm. Now the loss due to pre-stress, as we have discussed, the loss due to pre-stress is what? It is used by creep coefficient method, is found by creep coefficient method. I can write it as epsilon loss due to pre-stress. I could write it as due to creep, I could write it as epsilon C into ES, where this epsilon C, I could find it as epsilon C is equal to the creep coefficient into stress, creep coefficient into strain due to creep. That is, I could write it as the stress at the level of steel divided by EC into ES. This we have discussed, that is phi naught into ES by EC. I could write it as the modular ratio, that is M into FC. So we need to find here, now we need to find the value for phi naught, that is creep coefficient, and FC. So here the question, it is given the age of loading is not given, so we will assume the age of loading is 28 days. That is, once we have casted, we will first apply the load after 28 days. So the stress in concrete at the level of steel, that we know, we have done a lot of questions for that. That is, you have the pre-stressing force and the eccentricity due to pre-stressing force. So eccentricity due to pre-stressing force, so FC, the stress in level at the in concrete at the level of steel, I could write it as FC is equal to 23, that is P into 10 raised to 4 P divided by A, that is 3 into 10 raised to 4, plus P into E, that is 23 into 10 raised to 4 into P into E, into the section fiber considered at a distance of Y, that is eccentricity Y divided by I, 225 into 10 raised to 4, sorry 10 raised to 6. You will get this value as 10.2 Newton per mm square. So the F value is now you need to calculate the value for your phi naught, assuming the sides and bottom of the beam is exposed to environment. Before that, we will see how to find the value for your creep. So the creep coefficient, in order to find the creep coefficient, you need to have the phi t, that is the creep coefficient with respect to time is epsilon cc t by epsilon ci t naught. this epsilon is a creep strain at time t greater than t0. That initial t0 is the initial time and t is initial strain at the loading, and t is the initial time of loading. That is, at any time t is given, this one ECCT. So the creep coefficient phi t is given by this value. This beta t value depends on the grade of concrete and all. You can see here the calculation is based on the relative humidity. H0 is the notional size, and here also you can see it depends on the initial time, the FCK value. But the same thing, whatever things you have calculated using these equations can be calculated. Once you read this, you will understand. There is no need of explaining. So we can see here the same thing can be found out using this table based on the age at the loading corresponding to 70 years and relative humidity and notional size. That is, at what time you are loading the structure. If it is first day you are loading, okay fine, 7 day, 28 day, 90 day or 365 day. Notional size, that is 2 AC by U, we have discussed while calculating the shrinkage strain. Based on that, you have for relative humidity 50% and 80%, you will get the value for your phi naught, that is creep coefficient. So here in this question we will find the notional size as 2 AC by U. Here AC is the area of the concrete, that is I can write it as 2 into 300 into 100 divided by U is the perimeter exposed to the atmosphere, that is 2 times depth, 2 into 300, and the bottom width is exposed, that is you will get this value as 85.7 mm. Now in the question the relative humidity is not, it's given as 50%. If it is not given, you can assume this value. So based on that, you have the relative humidity value as 50% and notional size as 85.7. From this table, referring to this table, I'll get the value corresponding to 28 days of loading, and notional size as 85, somewhere in between these two. I'll get the value between 3.1 and 2.6. that is, you can interpolate this value, and once after interpolation you will get this value as 2.8. you will get the value for your phi naught as 2.8, that is the creep coefficient 2.8. Once you get the creep coefficient, you can find the loss due to creep as phi naught into m into fc, that is phi naught you got this 2.8, m value you have it is 5.4 and this is 10.2, fc is 10.2, so you can write 2.8 into 5.4 into 10.2. you'll get this value as 154.22 Newton per mm square. So the loss due to creep I can write it as 154.22 divided by 1000. What is the initial? Initial is 1200. 1200 into 100, that is 12.85% loss. So this comes to an end for the loss calculation. In the next class we will start with the second module, that is the analysis for flexural strength and the basis of the design parameters as well as the design philosophies. Thank you.